right? Okay. Okay. Testing. Yashu. Yasin. Right. Okay. Penuja. Right. Okay. Let's start. මොකද කවුද පේන්නේ නැත්තේ? ඔයාට මම පේන්නේ නැහැ. එහෙනම් මොකද්ද මේ කියන්නේ? ප්‍රොජෙක්ට් එක ලයිට් එක වැටෙන්නේ නැහැ නේ. තාම මේ පැත්තට හරවන්න කියලා කියන්නේ. හරි. හරි. ඔය දැන්ට බය වෙන්නේ නැතුව ඉන්න කලබල වෙන්න එපා. හරි. එක එක හදන්න. That's what we started a few weeks back. And we divided this angular motion into two main parts. Right? What are the two main parts? Rotational motion, and circular motion. And we have gone through the rotational motion comprehensively. Now, what we are going to do? Circular motion. It's a simple question, popular one, everyday question. What is circular motion? Close the books first. What is circular motion? What is it? Huh? What is circular motion? Object, a motion of an object moving in a circle, very bad. That's obvious. What is rotational motion? Object which is rotational motion is a rotational motion. Circular path, yes, path is circular and the center should be out of the object itself. Okay, comprehensive idea. We always have to mention that in detail. An object moving in a circular path, making an angular motion in a circular path, right? And that circular path is drawn from a fixed point which is out of the object. That fixed point is the center, right? So that is a circular motion. Yes. Correct.
On an object as it moves in a circle. When an object moves in a circle, its velocity changes direction. Since the velocity is changing, that means we have an acceleration. And we know from Newton's second law that if we have an acceleration, we have a net force. Now back to our spinning ball. For objects undergoing circular motion, the net force on the object is called the centripetal force. It's a weird sounding word, but it's Latin for the phrase center seeking. It's named centripetal because the centripetal force always points to the center of the circle. The ball has a tangential velocity, so if you suddenly cut the string, it would fly off in whatever the tangential direction was at the moment you made the cut. But assuming you don't cut the string and you keep swinging the ball's tangential velocity is constantly changing directions. This means the ball is accelerating, and the reason it's accelerating is due to the centripetal force. The centripetal force acting on the ball is constantly directing the ball towards the center of the circle, your hand. This, combined with the ball's velocity, keeps the ball swinging in a circle. The same centripetal force that keeps the tennis ball swinging in a circle also keeps roller coasters on the track as they go through a loop-de-loop. So the next time you're having a blast on a roller coaster, you can thank the centripetal force.
Right. So today's lesson is mainly about two things. What are the two things? Centripetal force, tangential velocity. Tangential velocity we have already learned. Centripetal acceleration and centripetal force. Right. Centripetal acceleration. So we're going to find centripetal acceleration. To find the centripetal acceleration, so I'm defining a circular motion of rate we are talking about an acceleration. We're talking about an acceleration. The problem is, how come there is an acceleration when it is moving with the same tangential velocity? Is it possible? Because we know that acceleration is about what? Change in velocity over time. So when there is no change in tangential velocity, how come there is an acceleration? Very good. That's what the video clip is all about. It is not velocity. Velocity, right? So we are talking about velocity. Velocity is a vector, and it is a magnitude plus a direction. Magnitude plus a direction. Magnitude plus a direction. So sometimes velocity will change because of the change in magnitude. Sometimes the velocity will change because of the change in direction. Shani, කන කාලා බීලා පොඩ වෙලා තිබ්බොත් ෆිසික්ස් ටිකකුත් ඉගෙන ගන්න හොඳේ. හරි නේද? ඒක කෑවට කමක් නැහැ. මොකද අපේ මේ ඉන්ස්ටිටියුට් එකේ නම? සියොකෙම් රෙස්ටුරන්ට්. කියන අපි ළමයි සාමාන්‍යයෙන් එන්නේ මොකටද? කන්න බොනේ ඒක තමයි ප්‍රධාන වැඩේ. හැබැයි පොඩි බ්‍රේක් එකක් හම්බුනොත් මොකද කරන්න ඕනේ? සර්කියුලර් මෝෂන් උ චුට්ටක් ඉගෙන ගන්න. හරි? right, very good. Thank you. Magnitude changes, there's an acceleration. Not only the magnitude, but also the direction. Now, this is a very good example. This is the best example in our syllabus. Objects creates what? Object creates acceleration due to changing direction. So that's the key point here in this. So now you can see the direction. This is kind of, northeast. So this is northwestern kind of direction. So there is a direction change. To understand the direction change, I resolve V to vertical up V cos theta, to the horizontal line V sin theta, and we come to this point and I resolve this one, right. Now we are in the process of finding what? Process of finding acceleration, right. So first of all, we try to find the acceleration for direction y direction. Acceleration for y direction. Acceleration for y direction. So acceleration is Vy minus Uy over T, Vy minus Uy over T. Vy is, what is Vy? What is Vy? V cos theta. What's the direction? Positive y direction. Uy. වැඩේ වෙනවා. චෙක් කරලා බලන්න. ගේන් ඉස්සර. Yes. Can. Yes. V cos theta again upwards. V cos theta again upwards. And that is positive y direction. And now V cos theta minus V cos theta is? V cos theta minus V cos theta is? I can't hear you. 0. Little bit disappointing start. Why? We wanted an acceleration, but unfortunately, what? There is no acceleration. Right? There is no acceleration. To y direction. Now we can try out x direction. So first of all, I take it to the negative x direction. When we take it to the negative x direction, right? When we take it to the negative x direction, right? Vx is V sin theta. What's the direction? Negative x direction. Ux is V sin theta to what? Positive x direction. V sin theta minus V sin theta. So V sin theta plus V sin theta, that is 2V sin theta over T. Is that clear? Now little bit happy. Why we are happy? Because there is an acceleration figure. There is an acceleration figure. Right. But at a glance you can see that this is not a kind of, finalized version of an acceleration, because it's halfway. Ax 2v sin theta t, theta is not well defined, t is not well defined, so we can't go like that. This is not a final version of the acceleration, but we are happy because we can obtain what? Some sort of an acceleration based on this. So let's go for the further work, and we bring these 2 points a little bit closer. Why? We are going to do a little bit of math. Tough. Calculus. Because we don't like theta. We like delta theta. So we need small angles. The delta theta. Small angles. We are dealing with small angles. Delta theta, small angles. Actually speaking, this delta theta is very small angles, not just small angles. We need very small angles. Give me a value for a small angle. 1 minute. Right, very good. I like that. පිටර කරන්න එපා. අනේ පිස්සුනේ. එළියට ගෙනියන්නකෝ ඕක. ටිලින් ටිලින් ගන්න මෙතන නත්තල් 100 ඇවිල්ලා වගේ. Right? 1 second, 1 minute. Right? We are talking about